So in assignment number 6, we're going to be solving quadratics, just like we did in assignment number 5, except we're now going to be solving them by graphing. So not everything can be done by factoring, and not everything can be done by using square roots. And so we have to have other methods that work in different situations. And so let's go ahead and take a look at some of these where we're going to be solving by graphing. So first problem looks like this, and let me get our calculators out so that we can solve this equation. If we try to factor this expression, we really won't be able to. There isn't anything that multiplies together to give us 4 that adds together to give us 6. Factoring is not going to work. Neither is square rooting. We can't subtract 4 and then eventually get the x squared by itself without the x there. So square rooting is not going to work. So there is a method that will work, and that is if we use our graphing calculator. And so let's go ahead and turn our graphing calculators on, and we're going to go through this equation step by step here. Right now, if we go to our graph, there's nothing there. I have nothing in my y equals, but I'm just going to type this in, and I'm going to replace the 0 with y. And so I'm just going to have y1 equals the x squared, so it's going to be x squared, and then plus 6x. Remember, the x is the xt theta n button, and then plus 4. And so I can go ahead and graph this equation, and we can see from the graph that it does equal 0. The y is 0 at 2 different places. And so what I want to do is find those 2 different places, find this point right here and this point right here. And so one way that we can do that is we can go to second trace or second calculate, and you can see that I have a menu now that I can find a minimum point, a maximum point, a point of intersection, or a 0. And so I'm going to go down to the 0 and click enter, and it's asking me for the left bound. So I'm going to go ahead and find this first, this point here, but I want to move my cursor to the left of it. That's my left bound. I want to click enter, and now it's asking me for the right. It wants me to move my cursor to the right of that 0, so I'm going to move to the right of that and click enter. I don't know why the calculator does this, but it's asking me, do you want to guess what it is? And if I wanted to guess what it was, I wouldn't be using my calculator, so I don't really want to guess. I'm just going to click enter. And it's telling me that the 0 is when x is negative 0.76392. And that's what this 0 is here. Well, that's one of the 2 solutions. We can see why it doesn't work to factor it. There's nothing that it'd be really difficult for us to be able to factor it and to get that number. But that's one 0. The other 0 is over here. And so we want to find that 0 the same way. We're going to go to second, calculate. I want to move down to number 2 because I want to find a 0. I want to find when the equation is equal to 0. And so this time I want to find the other 0. So I want to move to the left of that 0. I want to make sure my cursor's to the left. Click enter. Now it's asking me for the right bound, so I want to make sure my cursor's to the right and click enter. And I want to guess. I don't really want to guess. I'm just going to click enter again. The other 0 is when x is negative 5.236068. And you can see it says the y value is equal to 1 times, or 1, and then there's an e. That's scientific notation. That's a 1, but the decimal is moved 12 spaces to the left. 0.0000000. That's just the close the calculator could get to being it actually equal to 0. And so we can see here, if I move my calculator over, if I round to the nearest hundredth, that my 2 solutions are negative 5.25, that's this point, and the other one was negative 0.76. And so I can actually solve these equations, quadratic equations, by graphing them on my graphing calculator. So now that you've seen me do that problem, what I'd like for you to do is get your graphing calculators out and see if you can solve equation number 2 with your graphing calculators before I go ahead and do it on mine. So go ahead and pause the video, see if you can come up with what the zeros are on your own, and then restart the video and see if you did those correct. hopefully you've done that. And now what I'd like to do is go back to my calculator. I'm going to go clear this. And I'm going to type in this equation. It's y equals 3. Here's my x squared plus 5x. So plus 5x and then minus 12. And I want to graph that equation. And so there are two zeros. I want to find those zeros, so I'm going to go to second calculate, move down to 0. My first one that I'm going to find is the one to the right, so I want to make sure I'm to the left of the 0. So it's not important that it's below it, it's important that it's to the left of it. And so that's why I use my left arrow button. So I move to the left of the 0 and click enter. I move to the right of the 0 and click enter. I don't want to guess, so I'll just click enter again. And 1.3 repeating gives me a y value of 0. So that's one 0. The other 0 I can find by going to second calculate again, moving down to 0 or number 2, which is to find the 0. And now I'm going to move my cursor to the left of the other 0 and click enter. I want to move it to the right of the other 0 and click enter. And I don't want to guess, I just want it to tell me. And the other solution is -3. So these are actually incorrect answers. For this equation right here, we are going to have, it's 3x squared plus 5x minus 12. And the solutions that we came up with were 1.3 repeating, or 1 1/3, and then the other one was -3. So hopefully you are able to get those correct. All right, so with this problem, I want to, we're going to do it a different way. We want to solve it still by graphing, but this is not equal to 0. So one thing that we could do is we could subtract 4 and get it on the left-hand side and find the zeros just like we did with the first two questions. Or we could do this by graphing both the left side as an equation and the right side as an equation. What I mean by that would be something like this. We could let the first equation be simply x squared minus 2x for the first equation. Then we can go down and type a second equation, which is just y equals 4. So we have one equation is the left side of the equation. The other side of the equation is the right side of the equation. Then if I graph both of these, we're going to get two equations, two graphs. And the solution is going to be when this equation here is equal to 4. In other words, where those 2 points, those two graphs intersect. So instead of finding the 0, if we do it this way, we would go to second calculate. And instead of going down to number 2, we're actually going to go down to number 5. And we're going to find where they intersect. I'm going to find this point of intersection first. So I'm going to move my cursor close to this point where they intersect. And right now you can see I'm on the first curve. The first curve is the one that's the parabola. And so yes, that's the first curve. Now I'm on the second curve. And so you can see my cursor is moving back and forth on just the straight line, which is y equals 4. And so that's my second curve. I'll click enter. And again, it asks me if I want to guess, and I don't want to do that. I just want it to tell me what the correct answer is, which is -1.236068. And that would be what x would be that would give me a value of 4. And I could find the other one by going back to second trace, going down to my menu, which is intersect, and clicking enter, except this time I'm going to move my cursor really close to the other intersection point. And so I'm on my first curve, now I'm on my second curve. I don't want to guess, I just want it to tell me, which is going to be 3.236068. Also gives me a y value of 4. And so if I move my cursor up here, hopefully those are the ones that I had as my answer. I know this one is correct, 3.24 if I round to the nearest hundredth. And so I could have also done this by subtracting 4 from both sides and then finding the zeros. Just gives you another way to solve these with your graphing calculator. So as we look at this last question, there are several things that we want to do here. It says a stone is thrown from the edge of a cliff and its path is shown in the diagram. So we throw the stone up, it comes up to its highest point here, and then falls down to the ground. And the height of the height of the stone thrown over the cliff is given by this equation. So here's the force of gravity, negative 16x squared. It must be thrown with an initial upward velocity of 128 feet per second. What that means is if there was no gravity, it would go up 128 feet every second, but it would continue to go up and never come back down. It also means that when this person released the rock, it must have been 144 feet up in the air. That's the initial height of the rock that it was when they threw it. And so several questions we want to find here. The first one is, how high does the rock get? And so we're going to do this with our graphing calculator. And so I'm going to go back to my y equals. I'm going to clear both of my equations from the last problem that we did together. And I'm just going to type this equation into my calculator. It is negative. Now here's negative. It's not minus. It's negative 16x squared, and then plus 128x. This is x squared. Let me go back. X squared plus 128x, and then plus 144. So I'm going to go ahead and graph this on my calculator now. You can see it's really hard to see this because it goes up so high. It starts out 144 feet up and my calculator only goes up to 10. So what I'm going to have to do to start off with is change my window. So I'm going to change my window so that the x minimum, let's say I keep my x values the same. I can even make it start at, let's say, -2 and go to 10. My x scale could be 1, except I want my y scale. My y values could start at -10, but I want it to go up to, let's say, 200 here, and I'm going to have it count by tens. And so now when I graph it, might be a little bit better picture. It didn't get what I wanted. I wanted to see the vertex, and I didn't see that, so I'm going to go change the window. I need it to go up higher, so I'm just going to make it go up to, let's say, 600, and that should be plenty. That should be plenty of space for me to see the height. Let's go ahead and graph this and see if we see the height here. All right, and we do. And so we want to find how high does the rock get. Well, the first thing that we're going to do is go to second, calculate, or second trace, and we want to find the maximum point. So we're going to go to number 4, click enter, and again, here's my left bound. I want to move to the left of the height, and then I'm going to move to the right of the height, and that's the right bound. I don't want to guess. I just want it to tell me. The height is going to be in 3.9999 seconds. So in 4 seconds, it's going to be 400 feet high. So how high does the rock get? 400 feet high. How long will it take the rock to get to this height? Well, it'll take 4 seconds. So that's the first 2 questions. The second question is, when will it hit the water? Well, when it hits the water down here, or the ground, that means it's going to have a height of 0. And so that's going to be this point way over here on our graph. And so I can find what that point is because I want to find the 0. So I'm going to go ahead and find the left bound. Now I could just stop right here because I know I'm to the left of it right now. I'm just going to get a little closer to the left bound. So I'm going to move here and click enter. Now I want to move my cursor to the right of it. And so I'm going to make sure it's to the right and click enter. I don't want to guess. It's going to tell me that in 9 seconds, it's going to hit the ground. It's going to have a height of 0. So when will it hit the ground? It'll hit the ground in 9 seconds. And the last question, when will it be 76 feet above the ground? Well, in order to do this problem, we're going to have to type in a second equation. When will it be 76 feet above the ground? We're going to type in another equation, y equals 76, and graph it. It's going to be 76 feet right here. And so now I'm going to go to second, calculate. I'm going to scroll down to intersect, and I'm going to move my cursor close to this intersection point. And right now I'm on the first curve, so I want to click enter. Now I'm on the second curve. I could guess, but the intersection point is going to be that in 8.5 seconds it's going to be 76 feet high. And that's the answer to the second question, or the part D there. That's what our homework assignment is like. Good luck on this, and we will see you tomorrow in class.